Here is a very important test question based on relative velocity. We need to find the velocity of boat relative to ground so that it can reach from a point A to B, which is across the river downstream 1.5 kilometers. You can always learn from me by sending an email on the address given. Now, let us understand the solution and enjoy the journey of success. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss a very important test question. It is based on relative velocity. The question here is, a boat needs to cross a river from a point A to point B, where point B is 1.5 kilometers downstream. The boat can travel at a speed of 20 kilometers per hour relative to the water. The current is flowing at 12 kilometers per hour. The width of the river is 5 kilometers. Find the heading the captain should set to cross the river to point B. And part B is, find the heading the captain should set to return to the point A. Very important question. I'd like you to pause the video, answer, and then look into my suggestions. First thing is that you should draw a sketch to relate the given things. So we have a river whose width is given to us, and we are considering 2 points A and B. Well, let's consider point A on one shore. Point B is given to us as 1.5 kilometers downstream, right? So let us say point B is somewhere here. So that is point B. So from A, we need to go to point B. We are given the boat speed 20 kilometers per hour and the water current 12 kilometers per hour, width 5 kilometers. And this is 1.5 kilometers. Great. Find the heading the captain should set to cross the river to point B. So, because of the current, captain will aim somewhere, let us say here, and then will ultimately reach B, right? So that could be the diagram. So now you understand how do we draw this vector diagram. You can pause the video, answer the question. Let us see how do we solve it. Let's consider the point right across A as O, which forms a right triangle. And this triangle, so we're looking at triangle AOB, helps to find the angle at B, right? So we can say this angle at B will be what? Opposite and adjacent sides are given to us, so we can use tan ratio, right? So we can say tan of B is basically equal to 5 over 1.5, and that gives you the angle B as equal to tan inverse of 5 over 1.5, right? So let's find the angle B first. So we'll do 5 divided by 1.5. That gives you 3 1 by 3. And then shift tan inverse we get of the answer is 73.3. So we get this angle as 73.3 degrees. So we know this angle 73.3. Now, how do we solve the triangle? Well, we need to find the heading. That means we need to find this angle with the normal. You can say, let's say this angle is phi. What angle should the captain steer the boat? Let us say angle is phi. We know that the speed of the boat is 20 kilometers per hour. So we can say this is 20 and the current is 12. So that side of the green triangle is 12. Let's call this point here as C, right? Now, to solve this triangle, we can use sine law since we know the combination of angle B and the side opposite, right? So you can say that let's say we have this angle as theta. So we say sine theta over the water current, which is 12, should be equal to sine of 73.3 degrees over the side opposite, speed of the boat related to water, as 20. So that should help you to find the angle theta, right? So we can get the angle theta as equal to sine inverse of 12 divided by 20 times sine of 73.3 degrees, correct? So let's use the calculator. So we'll do 12 divided by 20 and times it by sine of 73.3, which is equal to 0.5746. And now we'll do shift sine inverse of our answer to get the value as 35 degrees. It is 35.07 degrees, right? So that is the angle theta, okay? So now you can write down the angle with the normal, or you could also write down the angle from the bank. Either way, you could write your answer, correct? Okay, so let's write down the angle from the normal, right? So that will be, once you know this angle theta, we know the angle B is 73.3, right? So this is also 73.3. So adding theta with 73.3 gives you the angle with the bank, correct? So the boat, we can write down that the captain should head, or boat heading will be equal to 73.3 plus the angle theta, which is 35.07, right? So that gives you 73.3 plus 35.07, and that is 108.37, or approximately 108.4 degrees. You get the idea. So that becomes the angle. So it is, as you can see in this particular case, this angle is actually more than 90 degrees, right? So that is the angle at which the boat is going to head to reach B. You get the idea, right? So I hope the solution is clear. Now, once you know that, you need to now work out the solution, the heading from angle from the point B to A, return journey, right? So we've done the first part, which is find the heading the captain should set to cross the river to point B, right? Now let's do the reverse, which is find the heading the captain should set to return to point A. Okay, so let's get back to this diagram. So now we have the situation that the river is flowing. Point B is 1.5 kilometers downstream. The angle at B is 73.3 in the given situation from A. We need to now come from B to A, right? That is the idea. Now, to reach here, the captain should head towards some point on this side, right? Let us say C. And because of the water current, the boat will ultimately come to A, right? So that becomes the situation. The speed of the boat is 20 kilometers per hour, and that of the river is 12. So that is the situation before us. And now we need to find the angle which verges from B towards A, right? Now tell me, how are you going to solve this particular question? So in this situation given to us, this angle here is 73.3. So we know the angle inside, right? So that is 180 minus 73.3. So let's do it. We have 180 minus 73.3, and that gives us 106.7. So this is 106.7. So now, since we know this angle 106.7, we can use the sine law to find the angle at B. Let's call this angle as beta. Okay, so sine of beta over the side opposite, which is 12, should be equal to sine of 106.7 over 20, and that will give us beta, right? So beta, the angle beta, will be sine inverse of 12 divided by 20 times sine of 106.7, correct? So let's find this angle now. So let's find sine of 106.7 and then multiply this by 12 and divide by 20. So we get 0.5764, and we'll do sine inverse of this. Shift sine inverse of the answer, and that gives us an angle of 35 degrees. So this angle here is 35 degrees. Since this is 35 degrees, 35.07, we can now find the heading angle either with respect to the bank, okay, so or either way. So this angle from here will be 73.3 minus 35, right? So let's say angle is theta. So from the bank, heading will be what? So heading will be 73.3 minus, let's say 35. Okay, you can round it to 35.1 degree if you want to. So it gives you 73.3 minus 35.1. It is 38.2 degrees. So the captain should really head from B at an angle of this angle of 38.2 degrees as we just calculated. Is that clear to you? Correct? So that is how we are going to solve this question. I hope the concept is absolutely clear. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'll be great. Thanks for your time and all the best.